Each week I prepare a new project, and for each one I always require a small modules, power sources, voltage regulators, amplifiers, battery chargers and protection, drivers, motor controllers, microcontrollers, programmers and much more. I would like to show you some of the most basic modules any maker would need for a basic everyday DIY electronics project. So I will show you what I have laying around and what I use for my homemade projects. And if you are a maker, maybe you should consider ordering some of these modules too. Remember, some time back I've made a top of sensors that you could use, and then another top video of displays that you could use with the Arduino. This will be another top video, but this time of modules and small components or tools that you could use for sure in a homemade electronic project. So guys, I hope this video will help you to make a general idea of what basic modules, crucial components and tools we have there for our projects. Make sure that you subscribe and hit the notification bell. A huge thank you to all my patrons for supporting my work. So guys, let's get started. This episode is sponsored by the PCB manufacturer company GLC PCB. Their main services are the 2-layer PCBs for only $2. Also 4 and 6-layer PCBs, the SMT assembly process where you will get the PCBs with all the components already soldered in place, and also the SMT stencil for soldering SMT components with solder paste. The quality of the PCBs is amazing. I use their services all the time and always get good results. For only $2, you have 5 PCBs of any color that you want. So go to glcpcb.com, upload the Gerber files of your design and order the PCBs in just a couple of minutes. What's up my friends, welcome back. I've divided all my modules and components in a few groups. One group is related to power sources, so everything related to batteries, chargers, regulators, limiters and protection modules. Other group is for controllers, such as the stepper motor driver, PWM power controllers, H-bridges and so on. We also have a group for passive components that any electronic maker should have, such as prototyping PCBs, breadboards, pins, connectors, jump wires and so on. I also want to show you a few options for microcontrollers and some of the useful programmers you should have laying around just in case. And the final group are just random modules that could be useful, also some actuators, light sources, amplifiers, speakers and all this kind of stuff. Okay, so let's start with the power source group. First thing first, you should always have some batteries around. The best for me are these lithium-ion 18650 batteries, and these are 3.7 volts nominal voltage and 4.2 volts when fully charged. Place a few of these in series and you can get a bigger voltage. You could easily find these in all laptop batteries, and if you want to buy them are just a few dollars, but make sure that you won't buy these extra cheap ones. These are usually fake or sometimes just filled with sand. I'm serious, batteries filled with sand. But anyway, at the same time, you could also buy this type of LiPo batteries with the same voltage. These could deliver more current, but are a little bit more fragile and sometimes more dangerous. Of course, for RC cars, for drones, and projects that require more capacity for longer time, you could also buy big battery packs for 3S, 4S and so on. Or maybe make your own pack, just as I did for my huge portable Bluetooth speaker project. Another option for power are power supplies. I always have a few of these small 5V or 12V supplies laying around, and you could connect this to 220V AC and this will give me the voltage for my project. This will cost you just a few dollars, and for basic Arduino projects this will work very well. The bigger is the supply, more power it could deliver. You could get this in a metal case like this one, or maybe a supply like this as an adapter here. Either one will work great. So guys, both the batteries or small supplies are a good option for providing power to your projects. Okay, so if your project uses batteries, you will definitely need to charge up those batteries at some point. The first module I want to show you is this one, and it's based on the TP4056 IC. This module has a USB input and works at 5V, and it can charge up a 4.2V battery. Also protected for overcharge and over discharge, and also limit the current. So you could merge this module with the battery from before and you get a decent power circuit. This other module here is the same, but this one doesn't have the current protection, only charging protection. On the same topic of battery chargers, these modules can only charge a 1S battery, meaning 4.2 volts. So what about when you have a battery pack of 2S, 3S or more? For that we use another module that is called a BMS, or Battery Management System. In my case I have the 1S module before. I also have a 2S BMS. We have this other module for 3S batteries, 4S and 5S, and there are also for 6S battery pack as I've used in the Bluetooth speaker project for that huge pack. All these are crucial if you want to safely charge your batteries. Now that you have the batteries charged up, not all projects will work at 4.2 volts, so you might need a voltage regulator. Actually, these are as important as the batteries for many of my homemade projects. Sometimes you want to use a low voltage battery and then boost that voltage up, but sometimes you prefer using a higher voltage battery and then regulate it to a lower voltage. For that we have the boost and the buck converters, the linear regulators or so-called LDOs, and sometimes we use transformer-based converters. This one here is a boost converter that could step up your voltage up to 28 volts and works with an input from 2 volts up to 24 volts and a current value of maximum 2 amps. This other one here is a buck converter and it can lower the voltage from 35 volts down to around 1 volt and it can deliver up to 3 amps of current. Sometimes I use these small modules. This one is a buck converter with a current limit of 3 amps and is very practical. I've used it in so many projects. For example, you can add 2 batteries in series and you get 8.4 volts. And then with this module, you set it to 5 volts and supply your Arduino, your sensors and so on. These other ones here, for example, are not variable, and one has a fixed output value of 3.3 volts and the others an output of 5 volts. And these converters are even smaller. Lately I have been using this smart converter. This one has a USB Type-C input. It could deliver more power and is controlled with just a simple push of a button. Press it once and the output is 3.3. Press it again and it's 5 volts and again for 12 volts. For more power you could also find a DC to DC converter like this ones that could give you 10 amps, 20 amps or even more, and it's always good to have at least one around just in case. Another practical converter is this one here, for those projects that are working connected to 220 volts AC from the main home outlet. This small module could give us 12 volts DC and 500 milliamps of current, and the input is 220 volts AC. It's very small and also quite practical. Okay, so then we have the LDOs. I always have a few AMS 1117 for 5 volts and 3.3 volts. I've used these regulators for basically all my Arduino projects, so it's always good to have these around. These are not as efficient, but are a lot smaller than switch converters. If you want a variable LDO, I recommend you to use the LM317. With a simple circuit as you can see here, just by varying the potentiometer value, you could change the output from 37 volts down to 1.2 volts and 1.5 amps. Another interesting module is this one here. This is another boost converter, but this one has a USB input, so you could connect a 5 volts cable to this one and then boost the voltage to maybe 12 volts or 20 volts. This module together with the USB battery charger could create an even better module. Actually, that's exactly what I've made with my own PCB design. This is a battery charger and protection and a boost converter PCB. So we have all the modules in just one board, and like this you can charge the battery to 4.2 volts with the USB input, protect it for overcharge and over discharge and current limit, and also set the output to 5 volts, 12 volts or any other value. You can order and mount my PCB from below, or maybe just buy this module here, the WeMOS battery charger. To finish with the power group, I also recommend you to buy some of these voltage indicators. You never know when you will need this for a simple project, just to know when the batteries are low or need a recharge. These are very easy to use. Just connect them to the battery and that's it. Some of these are just with a bar indicator, and some will have some numbers. Some are for DC and other for AC, and you must make sure of their maximum voltage. Okay, let's go to another group. This one is for motor drivers and power controllers that I use in a lot of projects. Starting with this one. This is a PWM power controller, in this case of 3 amps. With this you could control the speed of DC motors, for example, or the brightness of an LED strip, depending on the project. Other modules you should have just in case are relays. This one here is a coil relay and could be controlled with an Arduino. It will make that typical click and close the circuit, and it works with high voltage as well, so you could control basically anything with this. This other one here is a solid state relay. This one doesn't make that typical click, and can also be used with 240 volts AC and up to 2 amps. This one is also a little bit smaller, so you will decide which one to buy. If you want to control the speed and direction of the DC motors, you will need an H-bridge. One of the most common modules is this one here, that is based on the L298IC. This one could control up to 35 volts and 2 amps of current for each bridge, because this one is dual. It could control 2 motors at the same time. I also have this other one that is based on the MX1508IC, and this can also control 2 DC motors, up to 1.5 amps. This one is a lot smaller, but it doesn't have the heat dissipator, so it might get damaged faster. Another option that I have is this one here, and this one is based on the TB72583IC. Sometimes you want to use step motors in your projects. Well, for that you must have these cheap stepper motor drivers, the A4988. This is a very cheap solution and also very easy to control. I always have a few of these in my workshop. And if you want better results, I also recommend you the new Trinamic ones, and these are silent and have a better smooth output. These are controlled in the same way, but have more features and the best of all are silent. Okay, so these were the motor controllers. The next group are microcontrollers, prototyping and testing gear. For almost any electronic project, you should first make a breadboard test. So I recommend you to have at least one of these small breadboards. Buy more and you can merge them together, allowing you bigger circuits. I also have these old ones, and these are rare to find nowadays, but these are very helpful because they have banana connectors for cables from the power supply, and I can screw in place a wire and supply the rest of the breadboard. If you want a more permanent project, then go and order a few of these prototyping PCBs. These ones here are very cheap, but are not that good. The copper pads sometimes will fall off. For better results and also double layer, I recommend you these ones. These are a lot better. In my case, I use these prototyping PCBs a lot, almost every day. It's a very useful component. Also go ahead and order some PCB pins to have around. So order some female, some male and maybe some 90 degrees pins like these ones. These are just a few cents and are very useful. For testing you will also need some jump wires, so for a few bucks also order some of these to help you make the connections on the breadboard. Or maybe just order some of these solid wire jumpers. Now for the microcontrollers, well, the most common one is the Arduino. But this one also comes in a huge variety, both the original and the clones ones. For testing I always prefer the Arduino Uno. But for the final project, most of the time I use the Arduino Nano, because it's smaller and is easier to solder to the prototyping PCB. At the same time we have the Pro Mini version, but for this one, in order to program it, you will need an external FTDI programmer like this one, because the Mini doesn't have a USB input. The same as the Nano or the Pro Mini, we have this LilyPad version, and this one has the pins in a circular shape. Maybe this one will be better for a specific project, who knows. And you can always go and buy a bunch of the Atmega 328 chips and make your own PCB just by soldering the basic configuration of this controller. I've shown you this in so many tutorials. In this way the PCB can get a lot smaller because you only need the parts that you want for that specific project. You can buy 10 of these ICs for like $10 from eBay. Or maybe instead of the 328, you can buy the Atmega 8 or 16. If you want more powerful processes and bigger codes, I also recommend you the Arduino Mega. It has a lot of more pins and bigger memory. If you think the PCB of this one is too big, you can also find it in this other shape like this one. Other microcontrollers that you should have around are the ESP8266 for Wi-Fi connection and IoT projects. You can find this in the DIP format or the SMD version for smaller projects. It's a very powerful microcontroller. Also maybe go and buy the WeMAS D1 as well. And I also recommend you to have an ESP32. As for some other microcontrollers, I'm also starting playing around with the STM32, which is a lot better, faster, more memory and so on. This is a 32-bit microcontroller, and compared with the Arduino Uno, which is 8-bit. And for very small projects that don't require a lot of pins, you can order a very cheap micro, the ATtiny. Usually the ATtiny 85 or 13. You can even program this using the same Arduino IDE platform. And if you're not a fan of Arduino, you can also order a few PIC microcontrollers and play around with these ones. For that, I also recommend you to buy a PIC kit programmer. And by the way, as a separated group, you also need programmers. So you have the PIC kit, you might need a PCB module like this one for testing DIP microcontrollers. This one here is an ISP programmer. The FTDI programmer before is also very useful, and if you have ATtinys, you might want to use this small programmer with a USB input. Okay, so now for the final group, well, these are all sorts of modules and components. A lot of my homemade projects might look a lot cooler with LEDs, or even better RGB LEDs, so you could always have laying around some of these RGB LED strips, just in case. Maybe even go a bit more pro and use addressable LEDs like these ones, so you could control each LED separately. A lot of projects require sound. A very good and easy way of controlling sound is using a DF player like this one. This together with an Arduino could be programmed to control MP3 files from an SD card. I've used this module in so many projects. It has enough power to supply an 8 ohm speaker. I also have this other module here, but this one is not that good and a bit more difficult to control. And on the side, I also recommend you to have at least one audio amplifier. You could have, for example, this very cheap one based on the PAM8403 IC. But you could go a bit better with this one here, the TPA6120 amplifier. For playing around with microphone sound, I use this microphone preamp, which are quite good. And for more power, well, you have a huge variety of powerful amplifiers, of 100 watts, 200 watts or more. Oh, and since you have sound control and amplifiers, you will need some speakers. In my case, I've ordered a few of these small speakers kit to just have around, just in case I want to add sound to any of my projects. On side of this, you can also have a microphone module like this one, if your project requires voice or sound control. Some of these Bluetooth sound receivers are also quite useful. You could send and receive audio with Bluetooth and make your project wireless. This will cost you just $1 and have a great audio quality, have their own battery and charging USB port and a 3.5mm audio jack. Okay, so finally I recommend you to have some rotary encoders. These are cheap, easy to use, look a lot better than a bunch of controls and will improve your project a lot. A lot of my projects are using buzzers for sound notifications. This will work at 5 volts, are very cheap, and I also recommend you to have a few in your workshop. Other actuators you might use in your projects are magnetic actuators. You could use these for opening and closing doors, for example. These have decent force and are easy to control with a MOSFET, a relay or maybe directly with a button. Some of these are actuators, meaning a mechanical part will move and get in or out from the module, and other solenoids are just electromagnets. You can use these to attract metal parts, open and close doors and so on. Okay guys, so on the side of all this, always have some screws of different sizes and also nuts. Just in case, I always have a few plastic screws as well. Also get some bearings. These are very useful, and if you mix this with 3D printed parts, you can get even better results. These brass metal insertions are also very great with 3D printed parts. Magnets are also very useful for a lot of projects, so I also have a few of these, in all sorts of shapes and sizes. You should always have a few GT2 belts, some pulleys and even a few brushless motors, just in case of a radio control project. Finally, we have a lot of connectors, buttons and switches. All kind of interrupters, starting from these small breadboard buttons that you could use for tests or solder on a prototyping PCB. You can have bigger push buttons. Also LiPo battery connectors. DC female and male plugs. A rotary switch. PCB screw terminals. Banana plugs. Emergency stop switch. Slide switches. High voltage on and off switch. A key-based interrupter. Toggle switches, and lately I've also been using these small capacitive push buttons, and of course a lot of other type of buttons. Also make sure that you have a few normal potentiometers, or maybe some linear potentiometers like these ones. In my case, I always keep all the good thick wires, and for small digital connections I have a bunch of this 30 gauge solid wire. Pretty much all my homemade projects are using this thin wire. It's very good for small PCB connections. So guys, these are some of the most basic components I use for my homemade electronic projects. I hope that this will give you ideas for starting your own projects. Remember that sometimes making a project will teach you a lot more than books. Practice, fail, repeat, and you will get a lot better and better, and I'm sure that you have a lot of great ideas. Now you should also know what options are there. If this video helps you, give it a like. If you are new, make sure that you subscribe and activate the notification bell. I would like to give a huge thank you to all my patrons for supporting my work and enable me to get all these small modules. So thanks again and see you later guys.